I'm in my new office and I'm working on the plans for the desk that I'm sitting at right now. I want to make plans for this to sell on the website. And that does take a while. This is not a difficult plan to do when I compare it to other plans that I've made in the past, like box joint jigs and so on and so forth. Anything with moving parts in it makes it a lot more complex because you have to, lay everything out perfectly for those things to work together. And I'm intermittently checking in on the video I released this morning covering making this pad here for the armrest, and interesting comments on it. I said in the video that I'm using hot melt glue on there, and if there's any professional upholsterers in the audience watching it, they should chime in and say it's okay to do that. So I was looking for a little bit of validation on that. I wasn't looking for advice because I know that that stuff is going to hold just fine for this, and that's the point of this video, and that's what I want to talk about. It's putting things in perspective properly. You have to look at what we have here. We have an armrest on a desk, and the only load it will see is someone's forearm pressed down on it, very lightly actually. A lot of times my arm hovers over it. It's only when I'm completely at rest that I'm there like that. So it's not going to see a lot of abuse. So therefore, it doesn't have to be as ruggedly built as, say, a seat cushion. A seat cushion has to withstand the weight of the person moving around, getting up, sitting back down, trying to reposition. It gets pulled and stretched in every direction. So you have to build that so that it withstands that force. And this is a common thing that I keep running into when I post something on YouTube, a video, because usually I post stuff that's you don't normally see, or the way that I do things is not something that's, it's not the tried and true way. Usually I try to go outside that. I try to do things differently. I try to show a different way of doing things usually. And I'm able to do that because I have a lot of experience doing this kind of stuff. I've tried lots of different ways to do things. But there's one thing about the videos that I make. When I show it in a video and I say it works in the video, it works. You can take that to the bank. But there's a caveat. It works for the application. Everything in every part of life is application specific. It's like this armrest here. Use the hot melt glue to attach the fabric. It's not going to come off because it's not being abused. It's like joinery. I've got two samples here that I made up quickly this morning. This one is a box joint. I went out and cut that on my box joint jig in the workshop. And then the other one is just a simple butt joint. Now, on the surface, from a distance, these two things look exactly the same. The only thing is, this one is much stronger than this one. But this one will work for many different applications. It's only in extreme applications that you need to use this one. That is, you need to use it. If you're looking for something that just looks good, because box joints do look pretty good, so if you're looking for the decorative effect, then go with the box joint for that reason. More than likely you won't need the extra strength in most applications because the butt joint will work. I'll give you another example, and it has to do with me designing this desk. This desk is what I'm calling minimalist. That's the design is very minimal. The construction is very minimal. It doesn't have any complex joinery at all. I think I use biscuits in one location only, but you don't really need those either. Pocket hole screws would even work. And that's the way that I like to build things that are like this. I say this desk has to do a specific number of things. One of the things that it doesn't have to do is carry a lot of weight. Nobody is going to sit on this desk. If they do, if someone comes in here and sits this desk, they would be in trouble. Let me put it that way, first of all. They would be in trouble not only with me, but with humanity, because they'd be so stupid to try to sit on a desk like this. It doesn't have any sittable surfaces. You can see the armrest here. Nobody's going to sit on that. Maybe a little kid, okay? But even if a little kid sits on this armrest, it's not going to fail. Okay, so it's not going to take any heavy loads. It's carrying 2 monitors. I've got a computer down there. You can make the shelf bigger on the bottom and put other stuff like an UPS or something like that. You can mount a drawer underneath the top. That'd be fine. But otherwise, it's designed exactly for that load. It's actually stronger than it needs to be to carry that load. And that's the way I like to make things. Just strong enough or just slightly stronger than they need to be. There's no reason other than for aesthetics or to try to impress someone to overbuild. And that's a term that's underused actually. People say over-engineered. Over-engineered is a completely different thing than overbuilding. Overbuilding is kind of the stupid thing to do, whereas over-engineering is kind of stupid in its own right too, because there's a balance in there in everything. You have to try to strike that when you're building stuff or when you're learning about building stuff anyway. Experience is the true teacher, but you have to say, you know, how strong does that have to be? Do I really need to make it that strong? And that's the simple question. It's like this joint here. This joint is going to break, the butt joint is going to break a lot easier than this one will, but if this joint is not subjected to the load that's going to break it, then it's just fine. Otherwise, if you got a load to bear, use the other joint or use something stronger than the butt joint. Even driving screws in here, assuming the material was thicker to do that, driving screws in would reinforce the joint adequately. It won't make it as strong as this, but it will make it very much stronger. And the thing about mechanical fasteners like screws is that their failure point is usually not sudden, whereas your box joint here will carry out a lot of load and then it will fail catastrophically. Like there's no, there's no margin of error there, whereas screws will start to pull out, they'll start to crack the wood, but they'll still hold on a little bit. Eventually they will completely fail, but you have a little bit of safety margin. That's the reason why they, when they frame houses, they use nails. Nails are softer than screws. You can still use screws for certain things, but nails for the most part are used because they have that give, they have that yield. The structure can move slightly and your fasteners are not going to snap off and break and things will come crashing down on your head. Anyway, I hope that didn't come across as too preachy, because it wasn't meant to be. It was merely meant to get people to try to think about what they're doing, and that's important. If you really want to learn about, building stuff on a big scale, you know what I mean? Not to say big things, but to make it part of your existence, you build stuff, and so you have a deeper understanding of how things should be. And that starts with that. And it's, like I said, it comes usually with experience and paying attention to what happens when you do this and you don't do that.